Principles of magnetic prospecting. The principle of the magnetic method of prospecting is governed by the fact that irregularities exist in the distribution of magnetized material in the outer crust of the Earth, and such magnetic inhomogeneities cause variations. Measuring them with suitable magnetic instruments with a layout of observational stations form the prospecting technique. Thus, the whole object of magnetic prospecting is to measure systematically the anomaly field and interpret the magnetic inhomogeneities in terms of the geological structure. Magnetic prospecting on land with a portable instruments is a well-established technique, and followed in a routine fashion for the exploration of oil, gas and minerals. In oil exploration, it is used mostly for reconnaissance surveys, in combination with the gravity meter. The station spacing in this kind of survey varies from 0.5 kilometers to 3 or 4 kilometers. Provinces with aerial extensions of about a few thousands of square kilometers having a favorable oil structure may be covered by a reconnaissance survey employing gravity and magnetic methods. The purpose is to delineate the possible oil structures. However, in recent years, the reconnaissance surveys are being carried out by airborne magnetometer. The advantage of this survey is that it is quick and capable of giving information on regions that cannot be covered by foot or by an automobile. In mineral exploration, ground magnetic surveys are very widely used. The observational stations are normally taken at close intervals, establishing a grid location and line cutting across the mineralized zone. The survey is called magnetic detailing. Thus, the station intervals is usually laid at 10 meters to 100 meters, depending on the extent of the expected ore body. The magnetic surveys on land generally confined to measurement of vertical component, and rarely used as the horizontal component. If horizontal magnetometer is used, it is only to supplement the vertical magnetic data. After the total component measuring instruments have come for use, some total component ground surveys are done with a proton magnetometer. The data acquired by the total component measuring instruments require modified techniques of interpretation somewhat different from the one component data interpretation. There are certain corrections to be made for the magnetic data collected in the field. They are for the diurnal variation of the magnetic field, for elevation if the survey is conducted on hill slopes, and for the normal variation of the geomagnetic field if the reconnaissance survey of a regional nature. In the case of Schmitz-type magnetometer, an auxiliary magnet correction is to be incorporated if such a magnet is used to balance the extra field. After making appropriate corrections, specified above, the magnetic field variations in terms of gammas observed at different stations require a base station value to be subtracted. The base station is so located in the survey area that it does not involve the field of the causative body. The magnetic anomaly is thus a corrected value of the observation at a station from which the base value is subtracted. The reduced data thus obtained is presented in a set of profiles or as a contour map. These are called magnetic anomaly maps, and they reflect the subsurface magnetic inhomogeneities. It is a common practice that these anomalies are first qualitatively interpreted in terms of the subsurface geological features. The magnetic picture helps first to identify the location of the causative body, the positive and negative amplitude of the anomaly, its frequency and noise. Techniques are developed to filter the unwanted noise components from the observed anomaly. These are in some context referred to as regional, residual separation. After filtering the unwanted components from the observed anomalies, the data is interpreted quantitatively in terms of shape, strike extension and depth of the causative body, or the structure in oil prospecting. The most common method of interpretation in this respect is to match the observed anomaly with a theoretical anomaly calculated by assuming a geometric shape, strike extension, and depth of the causative body or the structure in oil prospecting. Downward and upward continuation, second derivative and spectral techniques are used to interpret the data quantitatively. There are certain limitations to these quantitative techniques, but they may be used successfully by judicious combination with the geological information. For example, the analysis by continuation downward is an attractive method for estimating the sedimentary thickness in oil exploration. Second derivative method is more useful for interpretation in mineral prospecting to enhance small-scale features located at shallow depth while upward continuation suppresses them.